Good morning, everyone. Sorry that we are a little late, but we just fixed the last technical issues, I guess. Yes. So, welcome to the second day of the Bolin Days. We will be starting this day with a result from something that we informally call the Valentine's Workshop. That was a meeting on the 14th of February in 2018, where the Bolin Center met the Human Science academic area at Stockholm University. And therefore we call it the Valentine's Workshop. And now we have some outcome from this workshop, because the workshop inspired collaboration between these two areas. And we have a whole session that is titled Climate Science in the Humanities, and we have 5 talks that are the outcome of this workshop. And I'm very much looking forward to hearing about the results. And the first speaker is Lisa Dellmuth, about climate change, natural disasters, and United Nations disaster relief.
Thank you. Thanks for having me. Hello, everyone.
Hang on a minute.
Oh, sure. Should I?
Yes. Sorry, maybe this is for the live stream, so just put it high there. Do you have a pocket?
I do, here.
Can I put this in there? And then just keep this somewhere. So.
Okay, now I'm well equipped. Okay. Well, thanks for having me. My name is Lisa Dellmuth. I'm Associate Professor of International Relations, and I was going to present together with Frida Bender from the Department of Meteorology, who unfortunately is home with a sick kid. But I suppose that's what happens in November in Stockholm. So I present our joint project on climate change, natural disasters, and United Nations disaster relief, which was generously funded, among others, by the Bolin Center. It has been funded between 2018 and 2019, so we're currently working on 2 peer review papers that we hope will be the main deliverables of this project. We start from a basic, well-known research problem. Future changes in climate will impact the frequency and severity of natural disasters, both in the developed and the developing world, and we have been repeatedly alerted about this by several IPCC reports, and a broad and lively global debate on these matters. Natural disasters, which basically are the consequences of extreme weather events, if they are recognized by a sufficiently large audience as causing damages. So natural disasters pose significant threats to human security these days, and thus to the international community. They're transboundary in nature. They cannot be addressed by nation states themselves, so we require effective responses by international organizations such as the United Nations, the Pacific Island Forum, and there are about 200 other international organizations that could be held accountable to addressing natural disasters. So in short, we need to understand how and why international organizations, short IOs, respond to natural disasters. There is a clear and striking gap in the existing social science literature on this matter. There is a vast literature on natural disaster consequences, but these have mainly focused on the influence of disasters on issues such as individual political attitudes, economic growth, and media framing. And much data comes from the United States. So we know very little about how international organizations such as the UN target disaster relief funding. So out of the vast repertoire of political instruments that international organizations can use to address disasters, to help people on the ground, we are interested here specifically in disaster relief funding. To tell you a little bit more about the types of natural disasters we are facing in the current world, this is based on a widely used database by disaster scholars, conflict researchers, other social scientists, and also United Nations agencies themselves. It's also the only database about natural disasters we have. It's called MDAT. And here you can see that about half of all the disaster types are made up out of floods of different kinds. We see also many different types of storms and droughts. And storms, for example, just to illustrate one example for you, storms are large rotating systems. They develop over warm oceans. They pick up most moisture in the air. They pick up speed. And then when they hit the coast, they usually decay. But before they do, they cause a whole lot of damage. So, for example, the world's most expensive tropical cyclone was Hurricane Katrina, which you surely remember in 2005, which caused the damage of about 800,000 houses and about 125 billion US dollars. Here we have collected corresponding data to match with this particular disasters data set. On the right-hand side, you see data from the United Nations pages on the types of the occurrence or frequency of natural disasters that is funded. So you see we're going to conclude that there's some correlation between the types of disasters out there and the funding they receive, but there's also large unexplained variation. So we're still interested in what can explain UN disaster funding. Just very briefly, some theoretical motivation. We contrast two large explanations for United Nations disaster relief funding. One is needs-based, the other one is political. And under each explanation, we can subsume a number of potential explanatory factors that we will later use in regression analysis, using United Nations disaster relief funding as a dependent variable. So needs-based explanations, for example, would posit that disaster magnitude or severity or country capacity explains United Nations disaster relief funding. Examples for political explanations could be trade relations between major donors, because arguably in the United Nations there's specific large donors who have exceptional influence, such as the United States. We could also imagine that countries' democracy levels or media coverage, public salience, public debate, and so on are motivators for why some natural disasters receive more UN funding than others. And we expect that these two explanations combine in explaining UN disaster relief funding. So on the research design, we have a natural science and a social science part. In the natural science part, we validate existing data on natural disasters using meteorological data. That's the part that Frida Bender is responsible for. And on the social science part, I'm responsible for then using these data on disaster magnitude to regress UN assistance to these different variables. On the validation part, we use different tools such as error interim reanalysis. We identify especially heat waves and cold spells using temperature, but also floods and droughts using precipitation. And I'm happy to afterwards chat with you about the various challenges that we meet. It's a very exciting exercise. And for the purpose of this project, we will extract disaster severity parameters or variables that could predict UN relief funding. I skipped the example and just show you one nice simulation that we have done. So for example, for heat waves between 2006 and 2017, that's the time span that we can observe. It seems relatively short, but it's actually, for a social scientist, it's quite a long time span. You get an impression of daily variation in heat spells above 30 degree Celsius at least. Okay, and then before I conclude, I would also like to show you some data from the social science part. Here you see the dependent variable, United Nations disaster relief payments in 1,000 US dollars, and you can see that this line here below, the total funding received by different natural disasters through the United Nations is only a fraction of overarching humanitarian aid. and is only a fraction of the total aid required, identified by different UN agencies that deal with different types of disaster aids and its consequences. And in concrete numbers, disaster relief makes up about 12% or $1.5 billion a year of total humanitarian aid a year. Okay, these are the results so far. I hope maybe next year I can present the results from our regression analysis and our publications. I just skipped this. Let me just conclude with some broader implications. First, we have contributed by relating disaster database to reanalysis. And in doing so, we can include meteorological quantification as a potential explaining variable of international aid, which we think was both fun and innovative. Second, we seek to advance theoretical knowledge on the conditions under which the international community responds to natural disasters, hopefully with validated and better meteorological data. And third, we will, in the future, probably next spring, formulate forward-looking policy-relevant conclusions for Swedish stakeholders and United Nations stakeholders in a policy brief. Thank you. I'm sorry for being on time.
Thank you very much, Lisa. I would like to invite one question or comment, a short one. Yes, I'll pass you the microphone.
Hi, I was just curious about fires. I didn't see anything about fires in your first slides. We hear a lot about fires all the time.
There are some wood fires, but they clearly make up a small fraction of disasters, and it could be that they're just here in this other category. I know there are wood fires in the data, but in terms of frequency and damage they cause, they're clearly minor. Most damage is caused by floods and tropical cyclones.
Thank you very much again, Lisa. Good morning. And our next speaker is Eva Machotka from the Department of Asian, Middle Eastern and Turkish Studies here at Stockholm University. And when we are ready with the microphone,
I don't have a pocket, but maybe.
We have a talk on art in the time of greenwashing. Welcome.
Yes, good morning, everyone. Thank you for this opportunity to contribute to the discussion on the climate science and the humanities. My name is Eva Machotka. I am an art historian. I specialize in Japanese art, and as my specialization doesn't seem like an obvious fit for this kind of conversation, maybe I will tell you a few words how I ended up here, really. So I've been interested in sustainability issues for a number of years. Already 10 years ago, I was working, when I was still in Japan, I was applying eco-critical perspective to the analysis of art and poetry in Japan. But basically, I started engaging with the interdisciplinary conversations on the sustainability issues when I came back to Europe, first at the Leiden University. And then I co-directed a big project there. Together with anthropologists, historians, and sociologists, we investigated what is the impact of consumption on sustainability. So that was our big thing. And then when I moved to Stockholm 2 years ago, I started talking or dating natural scientists. Yeah. So then the Bolin Center event, which was just mentioned before, the Pathways to New Collaborations, which was in February, the Valentine Day, was really important for me because it resulted in the collaborations with the hydrologist Fernando Jaramillo from the Bolin Center and from the natural sciences side. It also, and we wrote a paper together with other people as well, and it also introduced me to the Mirai initiative. I don't know if you're familiar with this, but it's a big, high-profile collaboration between the Japanese and Swedish universities, and they work also on sustainable. And that 2 years I spent at Mirai were really eye-opening for me, because I engaged in conversation with variety of disciplines, with different people working on, I don't know, engineers, hydrologists, marine ecologists, people who work on membranes, yeah? So it was like a great variety. I didn't understand anything at the beginning. I don't really think that I understand it now. But so it's not about that I learned about how the membranes work, but I actually, I think that I better understood these divisions between the two cultures, between the natural sciences and the humanities. And I also learned how maybe we can engage in the conversation, a productive conversation, despite these divisions, because we know that they are basically a major hindrance which stop us from resolving the climate change or other super wicked problems. So I also found people who would like to talk to me there, and we started talking about a project. This group of people include, for example, hydrologist Gia Destoni, or the water management specialist Mikiko Sugiura, or Wakatana Betak anthropologist. And we were interested in mainly in the unequal distribution of blue-green infrastructure in the urban centers, in Tokyo and Stockholm. So this was our major point of when we met, you know, point of interest. And of course, this issue could be addressed from many different perspectives, and this is what we are going to do. We can map, for example, inequalities in relation to ecosystem services and to social and economical factors. But what I am interested in, and well, I could contribute to the project like that, is basically I'm interested in the social conflicts that are generated by green redevelopment and the role of visual arts in resolving them and also aggregating them. Because art is a tricky thing. We never predict what effect the art will have on us. So basically, it is a mirror, but this is not a mirror of reality. It is a mirror, basically, whoever looks into mirror will see themselves. So that's why it's very difficult to understand these processes, but I think that they are important for the sustainability as well. So first, I would like to see maybe how I see the problem. So as we know, the cities are the sites of extreme social and ecological problems. And many cities engage in the green redevelopment. Yeah? And, but the problem is that this blue-green infrastructure is not equally redistributed among different communities and individuals. And the green redevelopment is supposed to resolve that problems, but in fact, it actually may lead to the green gentrification. Where, for example, the environmental improvement may increase the quality of life, may increase the prices, so the local residents, less affluent residents, are pushed out from the area, and the more affluent residents are welcomed. And culture and aesthetics, unfortunately, plays an important role in these processes, and that's why it deserves our attention. So the point is basically to link between the greenwashing, to explore the link between art washing and greenwashing, and I think that it is important for the sustainability science. So quickly, I would like to only show you an example of what is happening in Tokyo. It's not that Tokyo is unique. Tokyo is, you know, there are many different cities which have the same problems, but this is a result of the Sumida River Renaissance, a waterfront revitalization project which initiated in 2000. It is very high profile and it's supposed to be effective, but you know, the people who lived by the river, who was very polluted, it's really post-industrial area, very disadvantaged people, they were pushed away to make space for the parks, for the walkways, for the high-profile businesses, for the apartment, and for the museums, okay? So that's something, an economy doesn't explain everything, because equally important is attractiveness of the green infrastructure, really basically which induce people to engage with the blue-green infrastructure. Maybe not everybody would like to walk and be, you know, engaged in walking and being in the park. Maybe some people would like to do the gardening. But the space doesn't invite people, this type of space doesn't invite people to engage with this space, with the blue-green infrastructure in that way. So, and what happened what happened is that the managers of the Sumida River Renaissance tried to reconnect people to the river through using the cultural heritage and artistic heritage, for example, by using this kind of images. They are prints, early modern prints produced around middle of the 19th century as a model of social and environmental revival, and they focus on entertainment. So here we have a Sumida River by the bridge, and people are watching the fireworks, yeah? And today, they organize many events like that. For example, there are fireworks in Tokyo. They gather 1 million people in the same place, yeah, in the same night. Of course, fireworks are pollutants, so we can, there are a lot of issues there, but they succeeded on the social level. They reconnected people with the river. At the same time, they contribute to gentrification, for example, by constructing museums of this kind of art. This is done by the very famous, architects who received Pritzker Prize, for example, not a long time ago. So they contribute to gentrification, and also, really, this kind of project did not generate other ecosystem services, which the blue-green infrastructure is supposed to generate. So the question is, how can we assess positive and negative impact of art and cultural involvement in the social and ecological change? How can we reconcile them? And also how sustainability science can assess the role of art and art washing in these processes. And I think that interdisciplinary collaboration is the answer to that. And I hope that we will do it here at the Bolin Center. We will continue that work. And because one thing is clear, that environmental issues are not, the sustainability is not only an environmental issue, but it's also a cultural challenge. So this is what I prepared for today. Thank you very much.
Thank you very much, Eva. Question, yes, Karen.
Do you have an example where this sort of development has actually contributed to enhancing ecosystem services?
So far, I focused on the negative impact rather than positive, unfortunately, because I think that we have this, at least, I don't know if you're familiar with this, but in the art discourse, there is this concept of socially engaged art, and which has a, basically, art can deliver a positive social impact, but at the same time, socially engaged projects are very often co-opted and are used for art washing. So there is a conviction, and there's a number of projects when actually it worked. But if I can mention one in Tokyo, there is a Kanda River revitalization project where the children are participating. So this is really a socially engaged and is participatory, and they managed to redesign the river so it better serves the ecosystem services. But it's an experiment, it's very limited. It basically cannot be repeated easily and cannot serve as a model. It's rather an experiment than a model, a policy kind of guiding model. Yeah.
Thank you very much.
Thank you.
Next speaker is Jarsjö. Yes, conveniently sitting at the edge there, very nice. You'll be talking about functions and services of man-made wetlands in just a second.
Okay, great. So thank you. My name is Jarsjö. I'm from the Department of Physical Geography, and I will present the project together with human geography and ecology, environment and plant sciences deep here at Stockholm University. So our interest is about functions and services of man-made wetlands. You can see two examples here. To the left, it's an example from Halland in southwest Sweden. Many of these wetlands are actually recreated because 100 years ago and more, the trend was the opposite, that you drained the wetlands to get agricultural land. And now it has become very popular to recreate wetlands for various purposes. And we are interested in these mechanisms and the outcome of these mechanisms. And to the right, you can see another example from just outside Stockholm in Sollentuna, where they have created a series of wetlands, so a little bit on larger scales to get other kinds of functions. So our interests are, we were interested in how were the decisions to recreate wetlands actually made? And are there then differences in the functions of these recreated or even created for the first time wetlands in comparison with natural wetlands? In some cases they may look similar, but that doesn't say that the functions are similar. And what were the environmental goals and were they actually met? And this, I mean, with these objectives, you actually need to integrate approaches in human geography and ecology and physical geography to answer these questions. And one thing that is important to remember is that you might think that wetlands are well investigated, and that's partly true. I mean, typically, if you investigate a wetland, the focus tends to be on individual wetlands. So you can, for instance, measure and see that an individual wetland can trap nitrogen or pollutants, for instance. But the question is on the landscape scale, if you scale up, does this then help for the large-scale problems we have, for instance, with the eutrophication of the Baltic Sea, or to mitigate floods? Are these wetlands enough to do that? And that's another kind of question. So we emphasize here that rather little is known actually on the large-scale functions, even of natural wetlands. And that's one part of the research, to try to understand that. And on top of that comes then the man-made wetlands. So if we go to the question, why are wetlands reconstructed or constructed? You can actually apply for money to reconstruct a wetland from the Swedish Board of Agriculture, Jordbruksverket. And you can do it as a private person. So if you're interested in making a wetland, go to the website and apply. It's an online form. And you can do it as an individual. You can also do it as an organization. You can do it as a government. And you can do it also, it's not only from the Swedish Board of Agriculture you can do it from other sources as well. So this is a very complex process to understand how these wetlands come up. So we envision that there are many different goals to mitigate effects of hydroclimatic change. We have even seen when we're out that the kids want to go ice skating in the winter. So you can apply for a wetland, you get a nice view from the kitchen window, and hopefully there are also some ecosystem services, connected with that. So you can see the different possible goals. And the basic assumptions are then that the social and economic processes relevant for construction wetlands can lead to different geometries and locations compared to the outcome of natural processes for the natural wetlands. And that we have to account for. And so the baseline for us is the natural functioning of so-called natural wetlands. It's very hard to find a natural wetland in Sweden, actually, because things are changing due to agriculture and the forest management and so on. But we have a separate project. It was presented yesterday in RA7, dealing with how natural wetlands function on larger scales and the ecosystem services of that. So that's our baseline in this project. And we have some money then to monitor and also to do a research grant to actually get this research going. And there was one application that we submitted to the Swedish EPA about constructed wetlands as hydrological buffers. So we focus on one function to start with. How do these wetlands work as buffers? Can this buffering be maximized, and so on? And an example hypothesis we have is that if you optimize too hard on one function, it may be not constructive. So for instance, we think that man-made wetlands may better mitigate effects of floods if they are degraded or not optimally constructed for the original purpose, which might be nutrient purification and biodiversity. So one reason is if you have leaking water, if it's not perfect, then the water levels become lower when the flood comes, and then you have higher storage volume in the wetland when you get the flood. So that's one example of different objectives, different processes that are ongoing. So to put it simple, I'll stop with a question. The main question is if it's rational to design multipurpose wetlands instead of trying to optimize the functions or not. So that's an open question we hope to answer. That's it. Yeah.
Thank you very much, Jerka. I think we have time for one or two, or maybe even three questions. Shall I start here in the middle?
Thanks. It's very nice to have this overview, and wetlands have a long history. But I was missing one aspect of wetlands, and that was especially to climate and microclimate.
Yeah.
Because when I read the literature for 100 years ago, wetlands should be, not only taken away because they provide agricultural land. They had such a bad impact on the climate. The wetlands are representing places where the mist are coming, and they are also representing diseases, and they are representing all type of imaginations. Many of those were perfectly wrong and was just misunderstanding. But today we have also the carbon and the catch of the greenhouse gases.
Yeah.
So what's your feelings about those climate connections?
Exactly, yeah, you have these feedback loops the other way around also, so I think that's an important point. And I mean, for some people, if they do a wetland outside of their house, you might get more mosquitoes. So, and you might get another climate, microclimate. So that's yet another layer on top of this.
My question actually builds nicely on your question. Is one of the issues that we see with a lot of urban restoration projects looking at wetland areas is that they put a lot of money into establishing these wetlands, but not a lot of money into establishing evaluation criteria for how well they are at actually doing this. Is your project going to set up a series of criteria that incorporate these kinds of points about the hydroclimate changes and the carbon changes and evaluate some of these restoration projects or wetland recreation projects and sort of establish a checklist?
That's a very interesting idea. The first thing we want to do in this project is to see if the objectives that people state they have with the wetlands, if they are met or not on larger scales. And one example is actually from the very nice wetlands in Sollentuna where you can see. And they might trap pollutants and so on. And we walked downstream of these wetlands and we found basically an old dump of waste. So clearly you didn't see the whole picture there because downstream of the wetland you have new sources of pollution and so you need to scale up, and I think that's an important point. Yeah.
Thank you very much again. I think we need to move on in the interest of time and to be fair to the next speakers. Thank you again.
Thank you.
So we should have, yes, we do. Dag Retsö from the Institution of Economic History and International Relations. Talking about medieval normative text as a proxy source for meteorological normality.
I'm a historian, so I'm into climate of the past, trying to contribute to the construction of some reference point to climatic change today. And for that purpose, of course, we use documentary sources. We read documents from the past. And in Sweden, we are not very fortunate in terms of numbers. From the Middle Ages, we have very few documentary sources. In comparison with Europe, until 1550 or so, we have very little. Then, on the other hand, there is an explosion of documents in Sweden, and Sweden becomes one of the most well-documented countries in Europe. But before that, we have some methodological problems, any historian dealing with pre-modern times, and specifically when it comes to climate research. As you can see on the first graph up on the left, the total number is quite meager, and especially the difference between primary sources, that is letters and diaries, is something that is almost absent in the first centuries and then becomes more common in the 15th century. Before that, it's secondary sources, as chronicles and annals in particular. And when you look at the second graph to the or top right, the story of these sources is normally that of abnormal conditions, weather conditions, extremes of some kind. And the bottom graph here shows that most of these extreme weather data concerns the winter, which is not strange because an extreme winter in Sweden means, for example, a stop to shipping, which is one of the important themes of medieval Swedish history, the trade over the Baltic Sea with the towns of the Hanseatic League, for example. And the distribution between different types of data, you can see always also concerns mostly temperature, that is, statements about a very hot summer or an extremely cold winter. The problem for us is how to judge these statements on extreme weather. The question is extreme in relation to what? What was perceived as normal weather in those times? What was normality? So this is partly a story about mentality and human perception of weather, which is the first stage to understand how weather was really like, or climate was really like in the Middle Ages. And then I decided to look at some normative sources, for example, laws, provincial laws that were in force in Sweden until the middle of the 14th century, one law for each province, and then was replaced by a national law at that time. And in these laws there are several regulations that has to do with agriculture, for example. Fences, for example, should be mended at a particular date in the spring for letting out cattle. Already, okay. And as you can see, the dates vary from the south, 8th of May in Östergötland and Västergötland, to 17th of June in the north. And that this difference, this chronological difference, is of course a reflection that these dates reflect an agricultural physical reality. Spring simply arrives later in the north than in the south. So these dates can be seen as some kind of benchmark for people to think about the onset of spring. Inspection of fences in the autumn, the same thing, that is, marks the perception of the end of summer or the growing season. There are also other deadlines that are regulated in these laws. Collecting leaves, for example, should not be done after September 29th, for example. And there are also in folk, so-called folk wisdom, perceptions of typical normality. Here, the end of the period of safe ice covers, for example, 22nd of February. Most of these rules are fetched from the province of Södermanland, and 22nd of February should then be the earliest possible date for the onset of spring. And there are also ideas in the popular mentality about the best dates for sowing and planting of different crops. Lastly, there is also a huge collection in Sörmland, which I have looked upon, of folk magic or agricultural magic. Here, for example, the first example here, one saying says that if a hen drinks water dropping from the eaves or from the roof on Candlemas Day, 2nd of February, the ox will drink from a hole in the ice on Lady Day. That is a prophecy about an early spring. We don't need to care about the prophecy because you can't tell anything about the future from this. But the important part of this is the first part. If a hen drinks water dropping from the roof on a Candlemas day as early as 2nd of February, which means that that was quite possible to happen. Otherwise, the saying would not have survived. One difficulty with these folk magic sayings and proverbs and visions of omens importance is that we can't date them. We don't know really when they first emerged. But there is a way of, that is against the background of climatic change, these sayings could have grown useless after a while. The dates mentioned in these, for example, could change from one climatic period to another. But then the argument is that if these sayings would turn out to be useless, they wouldn't have survived in collective memory. And as long as we can read about them, as long as we can see that peasants follow them, that means that they were considered to be relevant still. And we have a point of comparison here. From the 18th century, we have quite a lot of peasant diaries, common farmers who wrote diaries about their daily activities. And they have been published to a large degree, so that they're easy to read. And there you can find confirmations of when and where, or even if, such ideas about normal weather were still considered to be relevant or not. And to finish this is, I don't have very much finished research results. This is an idea for a project that is coming up, trying to cover more provinces of Sweden than just Sörmland. But there are great possibilities to map some kind of climatic normality in documentary sources in this way.
Thank you very much.
Thank you.
Do we have a quick question or a comment? Yes, I'm coming.
I absolutely love this work. And I was wondering, do you think this is particular to Sweden, having just very people were literate, they wrote a lot, the farmers wrote diaries, or do you think this is something you might be able to find in other countries?
I suppose so. The literacy in Sweden in the 18th century was, as far as we know, surprisingly high. In the end of the 19th century, 99% of all adults were literate, for example. So literacy spread very rapidly here. How far back in time that goes, I don't know. But we know that in the 18th century already, we have a number of farmer diaries written by farmers, quite simple people, and where they, of course, were very occupied with weather conditions because that was their way of living. So in Sweden, we are perhaps a little bit more fortunate than in other countries, perhaps with the exception of other Scandinavian countries, Norway or Denmark. On the continent, I really don't know.
Thank you very much again. We are moving to the last talk of the session. This will be a paired talk, both by Per Holmlund and by Kerstin Lidén. It's about glacial archaeology, a new and unwanted research area. And I think you have to explain why it's unwanted.
Är den igång? Den här är på.
Det är någonting som händer.
Enable content. Enable content.
Ja, precis. Det var någonting med, det var det som kom. Jag såg inte det.
Nej. Ja, vi kan ta den här.
Kan du byta på dem som
Yeah, thank you. This is, we will have two talks and within the same project. And this is collaboration between physical geography and archaeology. And so after me, Kerstin Lidén will talk about the archaeological part. But with this view from the Swedish mountains, you can view what we have seen over the last 100 years, that we have a decrease in ice. And the ice is, and this has two implications. And one is that the surfaces are exposed, that has been ice covered for quite a long time. And the other thing is that these archives of climatic information is now vanishing from the mountains. So that these are the two aspects of this project. And I will just now give a background concerning the ice, and then Kerstin will talk about more about the project. If we look at a time series of temperature here is from this last 2,000 years, we can see that we have a cold period here about 1500 BP, and then a warmer period here about 1000 BP, and then we have this part that we call the Little Ice Age. And this means that glaciers have been smaller here, and that they were growing here, and they were growing here. But glaciers are very different in their way of behaving. If you're in a very maritime area, you have wet glaciers, and they are eroding, and which means that they are destroying whatever is underneath. And it's also that you are washing out much of the climatic information in the ice. And if we compare, for example, with the Ötztal man that they found, if this would have been beneath a temperate glacier, not only the man would have been gone, but also about 5 meters of the rock. So they are not really suitable for this purpose. But then if you go into more colder areas, where you have permafrost, glaciers can look like this. This means that they are melting on the surface, but they are preserving everything that is beneath them, because they are not sliding. They are stick to the ground. And then, of course, if you go in the high polar areas, you also preserve things, but they have not really been populated. This is also from a high alpine area, or a high polar area with typical glacier. This means that we have two basically polar glaciers that are cold, and we have temperate glaciers that are wet and warmer. But of course, then you subdivide these polar glaciers into two different categories. But of course, in the reality, you cannot really put all glaciers into these perfect groups. So we have this, what we call the polythermal glacier, which is where most glaciers are, because it means that you have some parts are frozen to the ground, some parts are wet and are eroding its substratum. And this is the way such a glacier may look like. They are typical with these long gullies on the surface here, which indicate that meltwater on the surface cannot penetrate the ice. So it's a runoff. But at the same time, you often have silty water here, which indicate that the glacier has also a part where it's eroding. But this means that along the sides and in front of such a glacier, you have possibilities of preservation. And especially at this site, a sled was found about 40 years or 50 years ago, which was from just in the beginning of the Little Ice Age that has been covered by ice. It's now on a museum. And then we have done mappings of glaciers and up in the Swedish mountains to find sites. Time doesn't really permit to go into detail with this now. But if we now look into areas, we have sites that we have found suitable for visits, and this was also what we have done. So a glacier, a small little ice patch or glacier like this is what we would call a subpolar glacier, which doesn't really erode, it's substratum, so it preserves what's ever been covered. And then there are other sites that this is a glacier which is famous in Sweden. It's Korsaglaciären, where we had the first measurements on glaciers. And you can see here is a medial moraine going here. And today you can see remnants of it out here, so it's almost nothing left. But this is a site where findings have been done that has been dated and published. And then there are some other sites that we had found, and some of them we have visited. This one last year, and you can see like this. This is a perfect place for to make findings. But it's one thing is that if it's perfect, the other thing that it doesn't necessarily do any findings anyway. And you can also, a glacier like this is about 4 square kilometers, and half of the site is below the freezing point. And then we have sites which are suitable for drillings. And this is one possibility. Again, we can't really go into detail, but this is one place that we have been discussing if we perhaps could do some drilling in the future. And then we have this little glacier here on the summit of Kebnekaise is more discussed in terms of global warming, that you can see this downgoing trend on the height. But this is also a site where but there is no reason to believe that there have been any human activity here in the ancient times. But if it would have been, this would have been a good site to find it. So I will end up here within one such a glacier, and with this leave the word to Kerstin. Thank you.
Okay, so short of time, but I will do this a bit fast. So glacier archaeology, an unwanted area. Of course, Pelle explained why it's an unwanted area. We don't want the glaciers to melt, but we want to find things that are melting out of the glacier, right? So this area, or this research field started almost with the find of Retsö, who was believed to have died in 5,300 years ago. And I mean, I think all of you know exactly a lot about this particular find. So we can say that this field started with him, but people have been finding things in glaciers or melting snow patches for a very, very long time, and people usually don't know what they find, and they think that it can't be very old, so they think it's more of recent times. So this particular snow show that was found on a glacier in Italy dated to 5,800 years BP, but the cartographer who found it when he was out working, he thought it was maybe 100 years old or so, so he kept it for 12 years in his office before he showed it to an archaeologist, and then it was dated. So these are the things that I think that all of you who are out there working there should be aware of. It's difficult to say if it's old or new or old. So is glacier archaeology good or bad? Yeah, if you're Indiana Jones, of course, it's very, very good, but it can also be very bad. Because melting ice in the Arctic it could be a nightmare, because things are melting out really fast, and we don't have the resources to take care of all the things that are melting out. And also, we also know that the preservation conditions for the organic material that we're looking for from these areas are being destroyed when the climate is changing and the environment is changing for the preservation of these things, as you can see in this graph, for instance. So we have a large responsibility as we archaeologists to take care of these finds that are melting out in order to protect our heritage. So there are lots of challenges in starting projects and regular inventories for doing this. In Norway, they've been doing this for 15 years or so. In Sweden, there's absolutely no regular inventories except for the ones that we've been performing, and also small inventories from the county museums in Norrbotten and Västerbotten, and also a little bit in Jämtland, but nothing organized really. these kind of things also should include the local population in the areas and indigenous knowledge and traditional knowledge, as shown here, because we also, not only do we know where the permanent snow patches are or the glaciers that would preserve these kind of things, we also need to have the knowledge of how people moved around in this area. So we should always include the local population in these areas. And also there is a lot of ethic issues in this respect, because people have been using these areas for a very, very long time period, but also in quite recent times. And this is an example of an individual, two individuals that melted out of a glacier 2 years ago in Switzerland, where the children of these two individuals are still alive. They had seven children, 5 boys and two girls, who lost their mother and father, and now they melted out 2 years ago. And these pictures, I just show the shoe of the female here. They were spread out all over the world. So lots of ethics that you have to think of also when doing this kind of research. So what kind of finds do we find? These are examples that are from Norway. You can find all these pictures on the webpage called the Frozen Secrets of the Frozen Past of the Ice, Secrets of the Ice. And these are Norwegian finds, and these are all connected to reindeer hunting. And you can see arrowheads. You can see up to the upper right there's a shoe, a leather shoe. To the lower right there are items that you use to frighten the reindeers, to force them to move in a particular direction. Organic materials that usually not preserved in normal environments can be preserved in these. This is a part of textiles that was found in Norway, and this is the actual find when it was cleaned. And you can see, if you find such a thing that you see on the upper left, you wouldn't believe that it was actually particularly old, but this is dated to 230, 390 AD, also before Christ. Shoes, items, normal items that you use for cookery, swords, Viking Age swords. This is a walking stick with a runic inscription. Of course, if you see the runic inscription, you would think that it would be old. And these were all from Norway. This is a Swedish find from Jämtland, an arrowhead. And this is more interesting because it still has the shaft, the wooden shaft to the arrow. Found in Machotka in Norrbotten. And this is the sledge that Pelle was talking about. There were actually 3 sledges that were found. And they were found by Walter Schütten in the 1960s. And now you can find them in Aite, in the museum in Aite. It's not only artifacts that we find. We usually mainly find ecofacts that can be used not only for archaeologists and the cultural interpretation, but also for natural sciences. In this case, it's a thrush that was found in this condition, and no one would think that it would be very old. It turned out to be 4,200 years old, and there were the heart, the liver, and the lungs, and everything was still intact in this bird. Also, other kind of ecofacts. These are all horse remains, horse shit, you can see down there, that was melting out of the ice, medieval horse shit. If someone's interested. And now I'm just going to say something about the projects that we've been involved with. We started out in 2017, and this is I'm going to show you quickly some pictures from there. This is Marcus Fjellström, a PhD student at the Archaeological Research Laboratory. This is how we work. This is how we find the things. You can see to the right. It's kind of difficult to actually identify things. And this is the result of the datings from the first year. And we found the reindeer that we found was dated to the migration period. This is from Korsja, also the glacier that Pelle showed pictures from. And you can see that we're carrying plastic bags, and you can see Anna Schütt carrying a stick. This is this stick, actually. And it's actually found from scientific work at Korsja Glacier, and it must be older than the 1960s when the glaciologists stopped using these bamboo sticks for measuring the glaciers. You can also see that we find modern things here, much more easy to date because they usually have the date written on them, this can here. And this are the radiocarbon dates that came from that particular site, from that year, and we had reindeer bones dated to the pre-Roman Iron Age. And this is from this year's expedition. We were up in in Sulitelma, and you can see also modern items that we find close to the glaciers melting out, maybe actually contributing to the climate change, these individuals. And here is also an interesting site, because you saw the pictures that Pelle were taking. He was taking pictures of the glaciers from different time periods, and he wants to identify the sites from where the pictures were taken. This is actually, this particular site is where that, there was a glacier expedition 100 years before we went there, and this is the site where they were. And if you lift the lid of this little rock, these rocks here, you can actually find the food containers that expedition used at that time. And you can see it, they're also dated actually, 100 years old. So this is just a picture of the people who took part in this year's expedition. That's Marcus Fjellström, it's me, it's Pelle to the right, and it's Karin Angebjörn, who's actually working outside here right now. And I just wanted to finish up with 2 more slides, because at this site we didn't find, we mainly found crap, and we didn't find any sticks, but we find other interesting remains from scientific work. If someone can help us date this particular item, it's a weather balloon that we found. There are still batteries. We couldn't find a date on the batteries, but if someone can help us with that, we would be very happy, because what we also do is that we actually collect all the rubbish that we find along the glaciers or where we walk, and then we're going to plot them on a map and see. We can actually date and see if it's winter tourism or summer tourism. Usually summer tourists don't bring beer cans with them, but people on skidoos do bring beer cans, so we can separate between winter tourism and summer tourism. But next year we're going to move further south. This has all been in Norrbotten. We're going to move to Västerbotten, because there we've spent some time doing excavations, and on these excavations, we found what archaeologists called chewing gums, archaeological chewing gums. It's actually a birch resin with tooth imprints. So then we know that people have been chewing on these imprints, and we can radiocarbon date them. And we can also do DNA analysis on the saliva that remains on these tooth imprints. And in this case, when we did more radiocarbon dating, they turned out to be 8,000 years old, which means that these are the oldest remains of human activities in Västerbotten. And in this area, we're also going to engage much more closely with the Sami population in order to identify, together with Pelle, identify areas where people have been moving around, and also where there are good permanent snow spots to find remains. Thank you very much.
Thank you very much. Very fascinating. Questions to Pelle and Kerstin? No?
We will be here
There
for
is
coffee.
one.
Oh, sorry.
Yeah, I know we will. Yes.
I mean, how do you actually, when you find a stick, I mean, how do you prioritize where you're actually going to spend money on carbon dating? I mean, you must come back with a lot of
Rubbish?
dating.
Yeah. That's the hardest thing, actually, because we cannot say. When we do find something, a bone, for instance, we cannot say if it's old or not. So we have to sort of make some kind of sampling within our samples. The oldest sample we found so far from the first expedition was the first bone we actually did find, or it was actually an antler at the Ekman Glacier. Pelle showed a picture from the Ekman Glacier. And when the helicopter landed, we just went off the helicopter. Oh, here's a reindeer antler. We collect that, and then we decided just to date items from all the different places we've been, and it turned out to be the oldest. It's impossible. But this one was actually tricky. We started to find small pieces of it, and at first it looked like wood, and then we realized, no, it has nodes. It must be a plant. And then we found this big stick, and obviously it was bamboo. So we don't have to date it, right?
Thank you very much again, all the speakers of the morning session. There is coffee outside. We reconvene at 10:30, and Alistair has a comment. But first, thanks again to everyone.
I just want to let you know, particularly people here from the humanities, that there will, and during the closing remarks today, another joint project between involving cross-faculty collaboration, the Climate Change Solutions course, is going to be presented by Arian Gustafsson. That's during the closing remarks, 4:30 today.